Well, you see that we're working on problem 6 now, and it's a simple derivative. The only issue is that our argument's a little complicated. Uh, Not so much complicated, but a little different, which will cause some complications as we apply the rules that we've learned. Uh, just as a reminder, the derivative of the inverse sine function of an argument is 1 over the square root of 1 minus that argument squared times the derivative of the argument. So let's begin our work. In this case then, applying directly, our u is 1 over 5x squared. So dy du, dy dx, pardon me, is going to be the fraction 1 over the square root of 1 minus our u value squared. But of course our u value is 1 over 5x squared. Then times the derivative of our argument, our u value. So that's the derivative of 1 over 5x squared. Well, as we move to the next line and we ponder what we've written, to begin to look how we might simplify this, of course we need to square this fraction. So we'll have 1 divided by the square root of 1 minus, when we square 1 we get 1, when we square 5x squared of course we get 25x to the fourth. So this is 1 over 25x to the fourth that's under this square root. And then times the derivative here. I tell you what I'm going to do before I calculate this derivative. I'm going to put it in a form that allows me to work a little better. And I'm going to write this as the coefficient 1/5 times x to the power negative 2. In other words, I can think of this as 1/5 times 1 over x squared, and 1 over x squared can be written as x to the negative 2. And so now that it's written as a power times x, a coefficient times x to a power, the derivative is easy to calculate. But let's postpone that for a moment, and let's look at this fraction. This is going to have its own algebraic challenges here, so let's go over and look at this. In fact, I'm going to look only at the denominator of this fraction right now. So what I have is the square root of 1 minus the fraction 1 over 25x to the fourth. Now we're not allowed to, it's normal that we don't leave fractions under a radical, and so this presents a little bit of problem. But I think what I'm going to do is I'm going to add these two expressions together. I'm going to write 1 in the form of 25x to the fourth over 25x to the fourth, so that I'll have a common denominator. So I have 25x to the fourth divided by 25x to the fourth minus 1 over 25x to the fourth. And so you see I've got a common denominator, and I can actually add those two fractions together. So we'll have a square root of, the numerator will be 25x to the fourth minus 1. And the denominator is itself 25x to the fourth. Now when we have the square root of a fraction, we can say that's the square root of the numerator. So the square root of 25x to the fourth minus 1 divided by the square root of the denominator, that'd be the square root of 25x to the fourth. And of course, this denominator, the square root, ends up just being 5x squared. So the result is a fraction whose numerator is the square root of 25x to the fourth minus 1, that's x to the fourth, divided by its denominator, which is just 5x squared. So I'm going to put that in this position. So I've got the derivative of y, with respect to x is a fraction which is 1 divided by this fraction I just determined, which is the square root of 25x to the fourth minus 1 divided by 5x squared times. Okay, now let's look at this derivative. Derivative here we'll say the exponent negative 2 times 1/5. Well, that's negative 2/5, of course. Times x to the power, well, reduce the power by 1. Negative 2 minus 1 is negative 3. Now, when we have a fraction, or when we divide by a fraction, which is what we're doing here, that's equivalent to multiplying by the reciprocal. So we're going to write this as, let's look at our derivative, dy dx. We're going to have the numerator 1 times the reciprocal of our divisor, which is 5x squared, over the square root of 25x to the fourth minus 1. So this is just 1 times the reciprocal of this divisor. Over here I'm going to write this a little bit differently. I'm going to write it as a negative fraction, so it's negative. Now, x to the negative 3 was going to be 1 over x cubed, so we'll end up with a 2 in the numerator and a 5x cubed in the denominator, just writing this as 1 over x cubed. Now let's make a little space here. A little faster than that. Now here's where we are. We're going to, of course, multiplying by 1 is not changing anything, and we're going to be multiplying two fractions together. One's positive and one's negative. So let's write the derivative of y with respect to x is going to be the negative, so you can see that clearly, of a fraction. Now let's look what's going to happen here. We're going to have these 5's cancel, aren't we? Now that we see this, because we're going to have a 5 in the numerator and a 5 in the denominator. And we're going to have x to the second over x to the third, so the x squared is going to cancel with 2 of these. So what we're going to be left with, let's kind of see this now. It's going to be a fraction, and it's negative, where in the numerator the only thing that's left is a 2, because this x squared is also canceling. And in the denominator we're going to have this factor, this radical, and we're only going to have x squared left in the denominator. Excuse me, x to the first power. So this is going to be ending up as x times the square root of 25 x to the fourth minus 1. That's a minus sign there. Okay, so final answer is the negative of the fraction, 2 over x times square root of 25x to the fourth minus 1. And as I think I mentioned earlier, the real challenge to this problem was just the fact that we had a lot of algebra involved to be able to apply the rule for taking the derivative of the inverse sine function.